So again, you do not need to write this down. But we're going to be working on task 98 and 99 today and graphing linear functions. So your work is going to look like this when you do it. So the first function that we're going to graph is y equals 3 over 2x plus negative 3. Now we know that this is m and this is b. Okay, m is not always the first number, but it's always the number that's multiplied by x. And the way to remember that is because the slope happens over and over. The y-intercept is always the constant, right? The number that's by itself, because remember the y-intercept only happens once. You might also see this written as 1.5 times x plus negative 3, because 3 over 2, 3 divided by 2 is 1.5. I like this way to write it because we can see the rise and the run. Remember, you need a rise and the run. But you might see it this way as well and have to realize that this means 3 over 2. All right? So this is the slope and this is the y-intercept. Slope and y-intercept. We like to start with the y-intercept when we graph it. And remember, that really means 0, negative 3. That is a single moment in time because it's a single number by itself. This happens over and over again because it's multiplied by x. And it's a rise over a run. It's 3 over 2, meaning you go up 3 boxes over 2, or up 1.5 boxes over 1, right? Which means the same thing. So if you ever see an equation written like this, y equals m times x plus b, this is a code telling you how to graph that line. Next line we're going to graph is very similar, but we're going to graph negative 3 over 2x plus negative 3. Very, very similar to this line. The only difference is the slope. You'll notice the y-intercept is the same, so they're going to both hit the y-axis at negative 3. And the slope this time is going to go down 3 over 2. Down 3 over 2. Now, just like the other one, 3 divided by 2 is 1.5. So you could also write this equation as negative 1.5 x plus negative 3. And commutative property, you could say negative 3 plus negative 1.5 times x. Notice here, the first number happens to be the y-intercept. So don't always go by what the first number and assume it's the slope. The coefficient of x is always the slope. The constant, the number that's by itself, is always the y-intercept. So if I was going to graph this, I know that I'm going to start at 0, negative 3, and then I'm going to go down 3 over 2, because negative 1.5 is the same as negative 3 halves. Now I'm going to graph another line. This line is going to be 0 over 1x plus 3. Now, here you'll notice the slope is 0 divided by 1. 0 divided by 1 is 0. So that tells me the slope is 0. The y-intercept here is a positive 3, so that's a different y-intercept than this one. Well, in this case, since 0 divided by 1 is 0, you might just write 0 times x plus 3. But as we talked about the other day, 0 times anything is 0. Therefore, you don't even need to write this, because this, no matter what x is always going to be 0. And 3 plus 0 is always 3. So y equals 3 is another way to write this equation. So this, you have to realize, is not the slope because it's not multiplied by x. It's by itself. So this is the y-intercept, 0, 3. And the slope must be 0. The only thing that could wipe out the x is 0. All right, 0 is the only powerful enough villain to wipe out an entire x value. So if you don't see an x in an equation, the slope must have been 0. Do a little detective work, right? No x value. The only thing that could have gotten rid of that x is a 0. Therefore, it tells me the slope must have been 0. Means up 0 over 1. As we know, you're going to have a nice straight horizontal line. Next equation we're going to graph today is 1 over 1x plus 2. In this case, the slope is 1 over 1. It's going to go up 1 over 1. So this is going to kind of go up over time. And the y-intercept is going to be a little different. It's going to be a 2. Here, since 1 divided by 1 is 1, you might actually see it written like this. But since we know 1 is 1 over 1, I like writing it like this better because I can actually see the rise and the run. Because remember, I need a rise and a run for a slope. And there's my y-intercept. All right. Now, because anything times 1 is just itself, sometimes you don't even see the 1 in front of there, right? If we don't see a coefficient in front of x, we can assume it's 1. Now, I know it's not 0 because the x is there, right? If the x wasn't there, then I know it must have been multiplied by 0. But since it's there, it couldn't have been multiplied by 0. We assume there's a coefficient of 1. And since we assume there's a coefficient of 1, we know the slope is actually 1 over 1. So don't get these two confused, all right? If there's no x, that means the slope is 0. If there's no coefficient written, we assume it's 1, meaning a slope of 1 over 1. All right. Next equation we're going to graph is negative 1 over 1 x plus 2. So the slope here is going to go down 1 over 1. The y-intercept is going to be 0, 2. And since negative 1 divided by 1 is negative 1, you could write it like this. Sometimes you'll see negative 1 times x plus 2. That really means negative 1 divided by 1. And sometimes, since you don't need to write the 1, you might just see a little negative sign in front of the x. So negative x plus 2 is the same thing as negative 1x plus 2, which is the same thing as negative 1 over 1. And again, we like to write the slopes as fractions because we can see the rise and the run. The y-intercept we don't need to write as a fraction because it's just a point, a single point in time, 0, 2. And the last line we're going to graph is positive 1 over, second to last line we're going to graph is 1 over 1x plus 5. So again, we have a slope of 1. So you might see it as 1x plus 5 or just x plus 5. And the last line we're going to graph is negative 1 over 1x plus 5, meaning we could graph it as negative 1x plus 5 or negative x plus 5. Now, you also might see that as 5 minus x, right? If you remember from last year, you could do keep, change. Remember, there's no coefficient in front of x. We could assume there's really a 1 in front of x. Keep, change. Add the negative, and you can see it's really a positive 5y intercept and a negative 1 slope. So if you ever see this, it looks like it doesn't follow the y equals mx plus b form, but it does. If you remember first, there's no coefficient. We assume it's 1. Second, if you remember, you can do keep, change. And then last, once we know it's addition, we can write it as negative 1x plus 5. And there is the equation that is a little more familiar to us. So all of these mean the same thing. So again, if you're going to be in the business of understanding the coding of algebra, you want to kind of see how each of these things are the same. So let's get to graphing. All right. First thing we want to do is start a new page, find a nice straight edge, and draw your y-axis. Then draw your x-axis, again, about halfway through. Now, let's start with our first line. 3 over 2x plus negative 3. I'm going to start with the y-intercept. The y-intercept is 0, negative 3. So I'm going to find my y-intercept, which means I have to find the y-axis, and then I have to go to negative 3. So this would be negative 1, negative 2, negative 3. That's right on the y-axis. There's where I'm going to start. Now, I'm done with this point. There's nothing else I can do with that. Now I need the slope. The slope is up 3 over 2. It's all positive. So I'm going to go up 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. Then you should see that this line would continue. And the way to continue it is go down 1, 2, 3 over 2. Down 1, 2, 3 over 2. Down 1, 2, 3 over 2. And you could literally do this as long as you have paper to do it on. Once we do that, we're going to make our straight line. And there we go. All right. Zoom out a little bit so you can see the entire, a little bit more of the paper there. All right. Next line we're going to do is put a little check next to that. Done. Now we're going to do this line. I'm going to start with the y-intercept, which is negative 3. And that's going to be right here. So we have a common point. And again, without the slope, I don't know where this is going. It's not until I look at the slope, which is the coefficient of x, in this case, down 3 over 2. Now I'm going to go down 1, 2, 3 over 2, down 1, 2, 3 over 2, down 1, 2, 3 over 2. Then I'm going to continue this up 1, 2, 3 over 2, up 1, 2, 3 over 2, and I will make my line connecting the dots as nicely as I can. And we have an X. So it started to look a little bit like the one we did on Monday, but it will be different. All right, so we started with that little X. And next one is 0 over 1 x plus 3. All right, so we did this one. So now I'm going to start at 3. So my y-intercept again is going to be 0, 3, because that's by itself. So now I look for the y-intercept, and it's right here, because this is 1, this is 2, this is 3. And from there, what do I do? It says up 0 over 1. And we know that's going to be a nice horizontal line. It means I go up 0 over 1, up 0 over 1, up 0 over 1. It just keeps on going straight. And I could continue it backwards if I wanted as well. And we go as far as you want. Next, I'm going to connect my dots. And now, again, it's starting to look a little bit like yesterday, but looks like maybe, or Monday, but maybe a little different. Let's see. Next, I'm going to graph this line. Now, this looks like the y-intercept is 2. All right, so I'm going to start at 0, 2. I already have that labeled on the y-axis. That's right here. But this time, my slope is 1 over 1, meaning I'm going to go up 1 over 1. I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And you'll see that's not parallel to this line, right? Because eventually they're going to cross. They don't have the same slope. So eventually these two would cross. And then to continue that line, I would go down 1 over 1, down 1 over 1. Just keep continuing that line over and over again. And connect my points. And you don't want to draw too hard because you know you're going to erase some of these lines later. What the heck is this? Well, we'll find out here. All right, so now I've done this one. So now this one's going to be very similar. I'm going to start at 2 again, but I'm going to go down 1 over 1. So I'm going to start at 2. I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And then I'm just going to continue this line backwards. Right? The way to do that is go up 1, back 1, up 1, back 1, up 1, back 1, and so on. And you could do that as long as you like, or you can just draw that line and extend it as long as you like, and it should continue. Oh, I see something there. Let's keep going. All right, so we can do this one. 2 more. This one has a y-intercept of 5 and a slope of 1 over 1. So let's go to 5 here. 1, 2, 3. This must be 4. This must be 5 on the y-axis. So there's my y-intercept. Now I need my slope. Tell me where to go. And it says I have a slope of 1 over 1. So another slope of 1 over 1. Now these two lines look like they're parallel. They'll never cross, right? These two. So I'm going to keep going, and then I'll just keep going this way too and extend the line as far as I can. And once I have that, this is looking a little messy. Oh no, I hope it doesn't get ruined. Hope Mr. Deal knows what he's doing. And there's some nice parallel lines at least. That's kind of cool. I see that. These are weird over here. All right, and let's try this one. Negative 1 over 1 x plus 5. Again, a y-intercept of 5 and a slope of negative 1 over 1. So I'm going to start at 1, 2, 3, 4, 5. That's right here. Now I go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, 1 over 1. And we'll connect those lines, or those dots. And we're done. Well, what the heck is this? Well, in this season of Christmas, I will tell you that it is important that we do one thing. And some people might say it is important that we give gifts. Yeah, that's important. Some people might say that it is important that we get some cookies out for Santa Claus. Yeah, that's pretty important, I guess. My kids, I told them a long time ago there's no Santa Claus. My wife thought I was mean, but really, in my opinion, there's so much real magic in the world that we don't really need it. Santa Claus, we don't need to make up magic. Right? Did you ever see the ocean waves crash on the beach? Did you ever feel the wind just kind of like gently caressing your face in a nice sunshine? Have you ever seen the stars? Right? There's enough magic in the world. So this Christmas season, I feel like there's really only one thing that we need to be thinking about. And that is love. We love you guys. Have a great Christmas, and see if you can make this on your own.